Hi scholars, let's look at TEK 4.4F. I can use strategies and algorithms, including the standard algorithm, to divide up to a 4-digit number by a 1-digit divisor. So this video is only focused on standard algorithm for long division. I'm going to start with 2-digit divided by 1-digit, do 3-digit divided by 1-digit, 4-digit divided by 1-digit. So let's get started. Before we get started, these are the steps for long division, and I always remember it by does McDonald's sell cheeseburgers regularly? Now, the first section is you're just going to go through the steps once, and so you will not do the bring down or repeat steps. You will just divide, multiply, subtract, check, and then whatever's left over is your remainder. If you have to go through the steps again, you're going to do divide, multiply, subtract, check, bring down. Repeat your steps, and then you'll do divide, multiply, subtract, check, bring down, and then it'll be remainder. But if you end up repeating again, you go through it again. You keep repeating until you have nothing left to bring down, and then it's your remainder. So you're going to be hearing me, using that terminology again and again through the video, so just be familiar with it. So long division is very easy. It's the same steps over and over. I strongly recommend that if you are weak in multiplication, that you put a multiplication table out to the side. So let's say you have 25 divided by 3. Okay, I would just make a chart for the 3's, like 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9. You don't even have to do that. You can also just list it. 3, 6, 9, 12, 15, 18, 21, 24, 27. You don't even need to go to 30 because you need to stay under 9. So just list the first 9 multiples of 3. So what you do is you see how many times 3 can go into this number. So 3 can't go into 2, but 3 can go into 25. The most times it can go in is this many, which is 8. So it can go in 8 times. And so that's your first step, division. Your second step is to multiply. You multiply 8 times 3, which would be this 24. So when you're doing this, you're saying the best I can do is 8, and that would be 24. Okay? Your next step is to subtract. You subtract that, and you have 1 left over. So you're saying the best I can do is a 3 by 8, and there will be 1 piece left over. Now, I want to quickly talk about what this symbol means. This is actually an array. They are saying that this is an 8 by 3 array, and there will be 24 in it, and there will be 1 left over. So that's why when they say 25 divided by 3, the best is 3 times 8, and then there will be 1 extra. This is the side of an array, and you are saying that these are the 2 dimensions. Let's look at another one. 31 divided by 6. So 6 goes into 31. They're basically saying, what's the best array you can make where 6 is on one side and, I want it to be 31. I want the product to be 31. So you can say, well, 1, 2, 3, 4, 5, I can make a 6 by 5. So the closest, the best I can do is a 6 by 5, which will be 30. So I divided, which is 5. I multiplied, which is 6 times 5 equals 30. Then I'm going to subtract, and then 31 minus 30 equals 1. And so then you make that your remainder. So you're saying I can make a 6 by 5, which will be 30, and there will be 1 left over, and that's why, 31. Okay, here's another one, 39 divided by 4. So they're saying I have an array. One side will be 4. I want to get 39 to fit in this array. So you can say, well, the best I can do, 1, 2, 3, 4, 5, 6, 7, 8, 9. I can make a 9 by 4. And a 9 by 4 is going to be 36 in that array. So if I have like a 9 by 4, okay, and they want 39, well, there's going to be 3 left over on the side. That's why when you subtract, you get, it's called your remainder of 3. Okay, let's look at one more. 41 divided by 5. Here are my multiples of 5. So if they're asking me 41 divided by 5, I have an array. 41 is the product. 5 is going to be on one side. What's the best you can do as far as making an array? So you can say, well, 1, 2, 3, 4, 5, 6, 7, 8, 9. I can make a 9. Oh, actually, no, that's too much. Sorry. I can make an 8 by 5, and that will give me 40. Okay? So if I have 40 in there, then that means there will be 1 left over. So an 8 by 5 with 1 left over. So your answer would be 8 remainder 1. Okay, 13 divided by 2. So if they want an array and one side has to be 2 and they want to get 13 in there, so the best we can do closest to 13 is 12. So that would be 1, 2, 3, 4, 5, 6 times 2 goes into 13. So a 2 by 6 is 12. There will be 1 left over. Whoops. Let me just draw a visual so you can see what's going on. You're saying there's a 2 by 6. Okay? There's 12 in here. They want 13. So what you're saying is, well, you'll have a 2 by 6 and then you'll have like 1 piece left over. So here's your 12 plus 1, 13 pieces. Hi scholars, let's look at TEK 4.4e. It says I can represent the quotient of a 4-digit whole number divided by a 1-digit whole number using arrays, area models, and equations. Now, if you saw my other video on representing the product of a 2-digit by 2-digit number, we also represented it through arrays, area models, and equations. An array is rows and columns, and like it's a faster way to multiply. Area models is very similar, but it's like broken up. So like, I'm just going to use this makes the most sense. So this is like 8 plus 2 and then times 10 or something like that. You've broken it up into parts, and then the equation is the math problem. So let's get started. So we always think of an array like an arrangement. We always think of it as an arrangement of, sorry, that was my phone. We always think of an arrangement of rows and columns. And when those rows and columns are multiplied, that gives us the total. So like, I'm just going to do a basic example. I have 3 rows and 4 columns. So instead of counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, I can do 3 times 4, that equals 12. So 12 is the product. 3 and 4 are the factors. Now, I also, in my other video for division, explained that the division symbol actually looks like this, because you want to think of this as the array, and this is the total number of pieces in that array. And you're telling what one side is and what the other side is. So it's supposed to look exactly like this. You are thinking that there are 12 pieces, and you have them in 3 rows. How many columns are there? And so that kind of gives us the setup. Now sometimes our arrangement might not work perfectly, and there will be leftovers. So I will also explain that too. So let's look at a visual using manipulatives. So I have here, so let's do 1, 2, 3, 4 columns, 3 rows, okay, and then we'll fill in the rest. So here is 12 pieces divided into 3 rows. Each row has 4, or how do I explain it? I have 12 pieces that are in 3 rows. Each row has 4. 1, 2, 3, 4. So that's a row. 1, 2, 3, 4. That's a row. 1, 2, 3, 4. That's a row. So this array is not only a representation of 3 times 4, it's also a representation of 12 divided by 3 equals 4, or 12 divided by 4 equals 3, which matches up with this division problem. Now, I want to explain a division problem with a remainder, because it's not always going to be perfect. So suppose I have 13 divided by 3. So what you're basically saying is I have an array that I want it to have 13 pieces, and I want there to be 3 rows. How many would be in each row? So if you look at it like this, I'm going to purposely put that in blue. So this is 13 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So when you're doing the division, you're saying 3 goes into 1, none. I always have my students put like a little X. 3 goes into 13 4 times. 4 times 3 is 12. 1 left over, 4 remainder 1. If you look at this division problem very carefully, you are saying, I always tell this story to my students, like someone is saying, hey, I want an array, I want 13 in there, and I want 3 rows. And it's kind of like when you solve the problem, you say, well, the best I can do if you want 3 is 12, a 3 by 12. And then there will be 1 piece left over. So that 12 plus 1 is your 13 pieces that they originally asked you to put in an array, but this is the best you can do. So your representation of the division problem using an array would look like this. You would have your 4 rows, or 4 columns as your answer, and then 1 remainder. So if the answer is 4 remainder 1, which is what we got from our division problem, you need to see 4 groups and 1 left over. If you see it this way, this is incorrect, because they are dividing by 3. Or actually, no, this is correct. I'm so sorry. You're dividing by 3 into 3 groups. There are 4 in each group with 1 left over. So sorry about the confusion. Let's look at another example. Okay, so suppose I have 21 somehow put in an array with 4 rows. How many in each row and how many left over? So you have to solve. 4 goes into 21 5 times. 5 times 4 is 20. So this is the best your array can be. There can be 20. There will be 1 left over. So you'll have a 4 by 5 with 20 in there, and then there will be like a leftover, because there's 21 total pieces, but the best you can put in an array is 20. So here's what your representation would look like in an array setup. So we said 4 rows, 5 in each row, 1 piece left over.